we're going to discuss the Pythagorean theorem. Nice big long word. It's actually the name of named after a guy named Pythagoras, who was a famous Greek mathematician, and also a guy who helped establish music. Anyway, long story. Pythagorean theorem. Pythagorean theorem is used to find the measure of any of the three sides of a right triangle. Right triangle. Okay? Not acute, not obtuse. It's only for right triangles, and it looks like this. A squared plus B squared equals C squared. Remember, there's three sides on a triangle, so this would be one side, the other side, and the last side. And I'm going to tell you how to figure out which goes where, all right? But the Pythagorean theorem, wonderful for finding any of the sides of a triangle, right triangle. Before we can do anything with r squared plus b squared equals c squared, we need to remember what squared means. So any of these numbers that are squared, I want you to remember that a squared, b squared, and c squared could be any number, any number. It could be a fraction, it could be a decimal. So anyway, these are just any number, okay? All right, so that means that these numbers, a, b, c, that means that we're multiplying times themselves twice. Okay, what does that mean? A squared could be equal to 5, and if it was equal to 5, what that would mean is that a squared is now 5, right? We're substituting. So 5 squared is equal to 5 times 5. That means it's multiplied times itself, right? 2 times, all right? So it's multiplied times itself. 5 times 5 is 25. What if a was equal to 7? Okay, excuse me, 7 right there. All right, so 7, and then, yes, if a was equal to 7, then a squared would be the same thing as 7 times 7, so our answer would be 49. And that's what a squared would equal to, okay? So that is squared. And the reason we say that is because look at this, squared. 2 squared is 2 times 2. 2 times 2 is 4. And we have 4 squares right here. Okay, does that make sense? 4 squared. If we had 5 squared, we would have 5 on one side of our square, 5 on the other, and we would have 25 squares altogether inside our square if we expanded that. The opposite of a square would be something called the square root. This is the opposite. And it kind of looks like a division sign. You see it over here, but it's got that little squiggle in front. So here I would say the square root of a number in any number. This is the opposite of what a squared number is. So, for instance, we said we had 4 little squares here, right? Now you guys remember that each side was 2. This is a way of doing that. We know there's 4 squares, so we do the square root of 4. Square root of 4 is the same thing as 2 times 2, right? That was 2 squared. So our answer is, if we have 4 squares, that means any one of the sides of this square is going to equal to 2. So our answer is 2. Okay? All right? It's a way of getting to finding one of these sides by itself. What if we had 25 squares in a square, right? 25 little squares inside a bigger square. Then that would be the same thing as saying 5 times 5. 5 on one side, 5 on the other side. 5 squared. So that means each side would equal to 5. Here, square root of 49. Okay, so square root of 49 is the same thing as having a big giant square, but it's 7 by 7, and we would have 7 squared. We have 49 little squares inside, so each side is equal to 7. Okay, now notice, the numbers repeat. They have to be the same exact number, right? So one of these is the answer, one of these is the answer, one of these is the answer. Okay? We're going to have to use the idea of squares and square roots to do the Pythagorean theorem. So now that we've reviewed that, let's take a look at how to use the Pythagorean theorem. Once again, the Pythagorean theorem is a way of finding the measurement of each of these sides, okay? So if we know 2 sides, we can figure out the third. All right, and this is a squared plus b squared equals c squared. Now, a squared and b squared, both of those, are the legs, but they're the legs of our right angle. So what we're looking for is the legs that go with this. So this is one of the legs, and here's the other leg, right? They're attached to that right angle. So it has to be those sides. The side that is opposite the right angle, okay? That's called a hypotenuse. Hypotenuse, okay? Let me erase this one because that's going to be confusing. But it's opposite the right angle, hypotenuse. That's going to be C, and that has to be C. Here, it doesn't matter which leg you pick. One of the legs is going to be A squared, one of the legs is going to be B squared. So, you know, you pick. If you want this to be A, go for it. If you want it to be A over here, go for it. But I already put A there, so I'm going to put a B there. Remember, hypotenuse has to be C. Okay? All right, so we're going to use this triangle, and I'm going to put some numbers in here. But first, I'm going to erase these sides. I'm going to just get rid of this so we're not so confused with what's going on here. So to show you how we use the legs and the hypotenuse with this, I'm going to tell you the numbers already to all three of them. And we're going to use it in an example to find out how both of these, when we find the squares of both of these and add them, is going to equal to this, okay? So let's make this equal to 3 inches. And we'll make this side equal to 4 inches. And we'll say that this one's equal to 5 inches. Okay? And we're going to do the math with these and see if both of these squared added together equals that. Okay? So I put the legs of the right angle here, and I put the hypotenuse there. Let's say 3 squared means 3 times 3. 3 times 3 is 9 plus 4 squared. Remember, 4 squared means 4 times 4. That's 16. Over here, 5 squared. 5 times 5. You know 5 times 5 is 25. So let's add these together. 16 plus 9, and guess what? It equals 25. This is equal to this sign, okay? And they found this out some time ago, and they saw that it works for all triangles. So we're going to use that to find what if we have a missing side. What if we didn't know this? We could have added these together, gotten 25. Now, what we're going to do is, these are the squares. We would be adding these, but we would have had to do this. We would have had to find the square root of 25. Remember, the square root of 25 is the same thing as this side over here. Square root of 5 squared. Remember, 5 times 5 gives me 25, right? 5 times 5 is the same thing as 5 squared. Each side would have to equal 5. Okay? Now, this can be a little confusing, but let's use the Pythagorean Theorem to find this side that's unknown. Now, it looks like the right angle is right here. So what we're going to do is we're going to say a squared plus b squared equals c squared. All right? So which are the legs of my right angle? The legs are this side here. That would be this side. Right? Here's the right angle, and the other side's here, so that would be that number. That has to be the legs on this side. We don't know the hypotenuse. We know this is going to be C. Okay? All right, so I'm going to put 6 squared, right, plus 8 squared equals C squared. All right? Let's do the math. 6 times 6, 6 squared is 36, plus 8 squared is 8 times 8, which is 64, equals C squared. Okay? All right. When we add these together, we get 100. That's C squared. Problem is, I know 100 is equal to C squared, but we need to figure out what it is. What is that one side equal to? All right. I'm going to adjust the camera for just a second. Pardon the movement. All right. So let's find the square root of 100. The square root of C squared. Okay, this side over here is the same thing as 10 times 10. So we're going to put down square root of 100 is 10 squared, 10 times 10. Square root of c squared. 10 times 10, one side of that square, that would be 10 times 10. That means one side is 10. C squared, one of those sides would be c. So our answer is right here. Okay, so see how this was 10 squared? See how this was c squared? We're just isolating this one number, this one variable in this case. All right? See where this comes there, that goes there. Okay. One other example. Here we go. This is kind of a different situation. We have the legs of our right triangle here, and this one we know is 12, but we don't know this one. So what I did was, I know that our formula is a squared plus b squared equals c squared. So I put down 12 for one of the legs here, and I just left this as a. Okay. We do know the hypotenuse. Remember the opposite side of our triangle, that's 13. So I put that for c. Okay. So here are legs. Here's the hypotenuse. All right. Let's go ahead and see if we can figure this out. A squared plus 12 squared is the same thing as 12 times 12, which is 144. The answer to 13 squared is 13 times 13 is 169. Okay, so we have these numbers, and what we're going to do is we're going to treat that as a one-step equation. And a one-step equation says that what we're going to do the opposite of what's here. Okay, so that means we're going to subtract 144 from both sides. I like to call this do-do. What we do to one side, we do to the other side. So we're subtracting 144 from both sides. Okay, that means that I have nothing here. So I bring it straight down, no variable. Here, these cancel out. So positive and negatives, they cancel out completely. When we subtract here, we're going to get 25. So a squared is equal to 25. Now remember, we don't know what a is, so we're going to take the square root of a squared. Square root of 25. This is also part of do-do. I did not mention on the last example, but I took the square root here, so I'm taking the square root here as well. Square root of a squared, that means a times a. So that would be just 1a. Square root of 25, you guys know that 5 times 5 is 25, so that's going to be 5. Okay, and let me just make sure that you understand that this is the same thing as 5 times 5, okay, 5 squared. So this is our answer. A should be 5. 5 meters in this case, okay? All right, we'll talk about it in class. See you soon.